The inspector's concern about a ground loop is valid. If the ground wire is connected to both the ground fault circuit interrupter, or GCFI, ground lug and the SPO ground lug, a ground loop could be formed through the rigid conduit. Your argument is also valid. The final 18 inches of non-metallic liquid-tight conduit effectively isolates the SPO from the buried rigid conduit, preventing any ground current from flowing through the conduit. Therefore, it is acceptable to connect the number 8 ground wire to the SPO ground lug, the GCFI ground lug, and the GCFI ground bar. The number 8 ground wire is sufficient for the 240 volts, 50 amp circuit. The National Electrical Code, or NEC, requires a minimum ground wire size of number 8 American wire gauge, or AUG, for circuits rated up to 60 amps. Based on the information provided, the grounding system is installed correctly. There is no need to disconnect the ground wire ends at the GCFI ground bar or to bond the ground wires together. Let's delve into the specifics of hot tub grounding to ensure a safe and compliant installation. The primary concern revolves around preventing electrical shock hazards and ensuring the proper operation of the GCFI. A GCFI is designed to detect even small imbalances in current flow, indicating a potential ground fault. It quickly trips the circuit, cutting off power and preventing injury. Proper grounding provides a low impedance path for fault current to flow back to the source, facilitating the GCFI's ability to detect and interrupt the circuit. Now let's talk about ground loops. A ground loop occurs when there are multiple ground paths between 2 points, creating a loop where current can circulate. This circulating current can cause nuisance tripping of the GCFI, create electromagnetic interference, and potentially lead to inaccurate readings from sensitive electronic equipment. In the context of a hot tub, a ground loop can arise if the equipment grounding conductor, or EG, is connected to both the GCFI ground lug and the SPO ground lug, with a metallic conduit run connecting the two. The rigid conduit provides an alternative path for ground current, potentially creating a loop. Your use of a short section of non-metallic liquid-tight conduit breaks this potential ground loop. Because it's non-conductive, the liquid-tight conduit prevents current from circulating through the rigid conduit. This isolation is crucial for ensuring the GCFI operates correctly and that no stray currents are present in the SPO's metal components. Moving on to grounding wire sizing, the NEC dictates the minimum size of the equipment grounding conductor based on the overcurrent protection device, such as a circuit breaker or fuse protecting the circuit. For a 50 amp circuit, NEC Table 250.122 specifies a minimum number 8 AWG copper conductor for the equipment grounding conductor. This size is adequate to safely carry fault current back to the source. Remember to always consult the latest edition of the NEC and local amendments to ensure compliance with all applicable codes and regulations. Now let's consider rigid conduit as a grounding path. While rigid metal conduit can serve as an equipment grounding conductor under certain conditions, it's not always the ideal or required method, especially for sensitive applications like hot tubs. The NEC allows metal conduit to be used as an EGC if it's properly installed with listed fittings and provides a low impedance path. However, relying solely on the conduit for grounding can be problematic if the connections become loose or corroded over time, increasing impedance and reducing the effectiveness of the grounding system. This is where the separate equipment grounding conductor comes in. The separate number 8 AWG ground wire provides a dedicated, reliable grounding path, regardless of the condition of the conduit. The combination of the rigid conduit and the separate ground wire provides a redundant grounding system, enhancing safety. Now let's look at the GCFI ground lug connection. Connecting the equipment grounding conductor to the GCFI ground lug ensures that any fault current is directed back to the source through the GCFI, allowing it to quickly detect and interrupt the circuit. This connection is essential for the GCFI to function properly. The GCFI monitors the current flowing in the hot and neutral conductors. Under normal conditions, these currents are equal. If a ground fault occurs, some current will flow through the equipment grounding conductor back to the source, creating an imbalance that the GCFI detects. The GCFI then trips the circuit, cutting off power and preventing electrical shock. It is important to differentiate between the equipment grounding conductor and the grounded conductor, or neutral. The neutral conductor carries normal load current back to the source, while the equipment grounding conductor provides a path for fault current. The neutral conductor is typically insulated white or grey, while the equipment grounding conductor is bare or green. Do not confuse the two, as this can create a dangerous situation. Now let's discuss bonding to metal water pipes. Bonding the main electrical panel to the home's metal water piping system is a common practice to ensure that all metal parts are at the same electrical potential. This reduces the risk of electric shock if someone comes into contact with a grounded metal object and an energized part. The water pipe bonding conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. It's important to note that plastic water pipes do not provide a grounding path and cannot be used for bonding purposes. So the metal water pipe bonding is crucial for overall electrical safety within the home. Now let's consider non-metallic liquid-tight conduit. The final 18 inches of non-metallic liquid-tight conduit serves as an isolation point, preventing the rigid conduit from becoming part of a ground loop. Because it is non-conductive, the liquid-tight conduit breaks the electrical continuity between the SPA and the rest of the electrical system. This isolation is crucial for ensuring the GCFI operates correctly and that no stray currents are present on the SPA's metal components. The short length of liquid-tight conduit also provides flexibility, allowing for easier installation and maintenance of the SPA. It's important to use listed liquid-tight fittings to ensure a watertight and secure connection. Now let's consider grounding electrode system. The grounding electrode system typically consists of a combination of electrodes, such as ground rods, metal water pipes, and concrete encased electrodes, or UFRs. These electrodes are connected together to form a low impedance path to earth. The grounding electrode system provides a reference point for the electrical system, helping to stabilize voltage and prevent transient overvoltages. It also helps to dissipate fault current into the earth in the event of a ground fault. The grounding electrode system should be properly installed and maintained to ensure its effectiveness. Now let's discuss local amendments and inspections. It is crucial to check with your local electrical inspector for any amendments or interpretations of the NEC that may apply in your jurisdiction. Local codes may have additional requirements for hot tub grounding and bonding, such as the use of specific types of connectors or the placement of ground rods. The electrical inspector is the final authority on code compliance and can provide valuable guidance on ensuring a safe and code-compliant installation. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing the work yourself. Now let's consider other types of scenarios. In some installations, the hot tub may be fed from a sub-panel located closer to the SPA. In this case, the equipment grounding conductor should originate at the sub-panel and run to the SPA, along with the circuit conductors. The sub-panel should be properly grounded back to the main electrical panel. Ensure that the neutral and ground conductors are properly separated at the sub-panel. The neutral conductor should be isolated from the sub-panel enclosure, while the equipment grounding conductor should be bonded to the enclosure. Improper separation of neutral and ground conductors can create a parallel neutral path, leading to ground loops and nuisance tripping of the GCFI. Now let's discuss maintenance and testing. Regularly inspect the grounding system for any signs of damage or corrosion. Check the connections at the GCFI, SPA, and grounding electrodes to ensure they are tight and secure. Periodically test the GCFI to ensure it is functioning properly. Most GCFIs have a test button that simulates a ground fault and causes the device to trip. If the GCFI fails to trip when the test button is pressed, it should be replaced immediately. Now let's discuss the importance of documentation. Keep a record of all electrical work performed in the hot tub, including the date, description of work, and any test results. This documentation can be helpful for troubleshooting any problems that may arise in the future and for demonstrating compliance with electrical codes. It's also a good idea to take photos of the installation before covering up any wiring or connections. These photos can be useful for reference if you need to make any repairs or modifications in the future. Now let's consider future upgrades. If you plan to upgrade the hot tub in the future, be sure to consider the electrical requirements of the new spa. The new hot tub may require a different size circuit breaker, wiring, or GCFI. Consult with a qualified electrician to ensure that the electrical system is adequate for the new spa. It's always better to plan ahead and make any necessary electrical upgrades before installing the new hot tub. Now let's discuss common grounding mistakes. One common mistake is to use the neutral conductor as the equipment grounding conductor. This is a dangerous practice that can create a shock hazard. The neutral conductor should only carry normal load current, while the equipment grounding conductor should only carry fault current. Another common mistake is to improperly size the equipment grounding conductor. The equipment grounding conductor should be sized according to NEC Table 250.122, based on the overcurrent protection device protecting the circuit. Using an undersized equipment grounding conductor can create a fire hazard in the event of a ground fault. Now let's consider professional installation. While it may be tempting to save money by performing the electrical work yourself, it's always best to hire a qualified electrician to install the hot tub electrical system. A qualified electrician has the knowledge, skills, and experience to ensure that the installation is safe, code compliant, and reliable. They can also help you troubleshoot any problems that may arise in the future. Now let's discuss additional safety measures. In addition to proper grounding, there are several other safety measures that should be taken to protect against electrical shock hazards. Install a lockable disconnect switch within sight of the hot tub to allow for easy shutoff of power in case of an emergency. Ensure that all electrical equipment is properly rated for outdoor use and protected from the elements. Keep electrical cords and appliances away from the hot tub to prevent accidental contact with water. Now let's discuss lightning protection. While proper grounding can help to protect against electrical shock hazards, it does not provide complete protection against lightning strikes. If you live in an area with frequent lightning activity, you may want to consider installing a lightning protection system. A lightning protection system consists of a network of conductors and ground rods that are designed to intercept lightning strikes and safely channel the current into the earth. Now let's summarize the key takeaways. Proper grounding is essential for hot tub safety and the correct operation of the GCFI. Prevent ground loops by isolating the spa from the rigid conduit with a short section of non-metallic liquid-tight conduit. Size the equipment grounding conductor according to NEC Table 250.122. Bond the main electrical panel to the home's metal water piping system. Consult with a qualified electrician to ensure that the electrical system is safe, code compliant, and reliable. Now let's discuss future technologies. As technology advances, there may be new grounding methods and technologies that become available. Stay informed about the latest developments in electrical safety and consider incorporating these technologies into your hot tub installation. For example, arc fault circuit interrupters, or SIs, are becoming increasingly common in residential wiring. SIs detect arc faults, which are a common cause of electrical fires. Now let's discuss education and training. Consider taking an electrical safety course to learn more about proper grounding techniques and electrical codes. There are many online and in-person courses available that can provide you with the knowledge and skills you need to safely work with electricity. Remember that electricity is a powerful force and should be treated with respect. Now let's talk about the NEC and its updates. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It's important to stay current with the latest edition of the NEC to ensure that your electrical installations are safe and code compliant. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or access it online through various subscription services. Now let's consider specific GCFI requirements. Refer to the GCFI manufacturer's instructions for specific grounding requirements and recommendations. Some GCFIs may require specific grounding configurations or have limitations on the length of the equipment grounding conductor. Always follow the manufacturer's instructions to ensure proper operation and safety. Now let's consider voltage drop. Ensure that the circuit conductors are properly sized to minimize voltage drop. Excessive voltage drop can cause the hot tub to operate inefficiently and can damage electrical components. The NEC provides guidelines for calculating voltage drop and selecting the appropriate conductor size. Now let's talk about wire types. Use the correct type of wire for the hot tub installation. THHN or THWN conductors are commonly used for wiring hot tubs. These conductors are insulated with a thermoplastic high heat resistant nylon jacket or thermoplastic heat and water resistant nylon jacket material and are suitable for use in wet locations. Ensure that the conductors are properly sized for the ampacity of the circuit and aerated for ambient temperature and conduit fill. Now let's consider conduit fill. Do not overcrowd the conduit with too many conductors. The NEC specifies the maximum number of conductors that can be installed in a conduit of a given size. Overfilling the conduit can damage the conductors and reduce their ampacity. Now let's discuss weatherproof enclosures. Use weatherproof enclosures for all electrical connections and equipment located outdoors. Weatherproof enclosures protect electrical components from the elements and prevent corrosion. Ensure that the enclosures are properly sealed to prevent moisture from entering. Now let's discuss corrosion resistance. Use corrosion-resistant materials for all electrical connections and equipment. This is especially important in coastal areas where salt air can accelerate corrosion. Copper conductors, stainless steel screws, and coated conduit are examples of corrosion-resistant materials. Now let's discuss torque specifications. Use a torque wrench to tighten all electrical connections to the manufacturer's specified torque. Over-tightening or under-tightening connections can lead to loose connections, overheating, and electrical failures. Now let's consider lockout-tagout procedures. Follow proper lockout-tagout procedures when working on electrical equipment. This involves disconnecting the power supply and applying a lock and tag to the disconnect switch to prevent accidental energization. Lockout-tagout procedures are essential for preventing electrical shock and arc flash injuries. Now let's discuss personal protective equipment, or PPE. Wear appropriate PPE when working on electrical equipment, including safety glasses, gloves, and insulated tools. PPE protects against electrical shock, arc flash, and other hazards. Now let's consider first aid. Be prepared to administer first aid in the event of an electrical shock injury. Know how to perform cardiopulmonary resuscitation, or CPR, and have a first aid kit readily available. Call emergency services immediately in the event of a serious electrical shock injury. Now let's discuss emergency procedures. Develop and practice emergency procedures for dealing with electrical hazards. Know how to shut off power to the hot tub in case of an emergency and have a plan for evacuating the area if necessary. Now let's consider record keeping. Maintain accurate records of all electrical work performed in the hot tub, including permits, inspections, and test results. This documentation can be helpful for troubleshooting problems and demonstrating compliance with electrical codes. Now let's discuss ongoing maintenance. Perform regular maintenance on the hot tub electrical system to ensure it is operating safely and efficiently. This includes inspecting wiring, connections, and equipment for signs of wear and tear. Now let's talk about professional inspections. Schedule periodic inspections by a qualified electrician to ensure that the hot tub electrical system is code compliant and functioning properly. A professional inspection can identify potential problems before they become serious hazards. Now let's talk about homeowner responsibility. As a homeowner, you are responsible for ensuring that your hot tub electrical system is safe and code compliant. Take the time to learn about electrical safety and perform regular inspections of your hot tub. Now let's consider continuous improvement. Continuously seek out new information and training to improve your knowledge and skills in electrical safety. The electrical industry is constantly evolving, and it's important to stay up to date on the latest technologies and best practices.